Okay, so number 7, you had f of x. Could you read that to me? Because I have the wrong book in my hand. What was it? It was like
f of x equals 1 plus k to the x.
K to the...
Oh, sorry, x to the k.
Okay, yeah, like this. 1 plus x raised to the k. And we wanted to show that the linearization of that was 1 plus kx, right? 1 plus kx. So remember that the linearization is the tangent line of that. So before we even get started, so what does that mean? Well, we're going to jump to a different page. Whoops. So remember that when we write the tangent line, it's y minus y sub 1 is equal to m x minus x sub 1. Okay? And keep in mind, we're focusing on a point where the point is a comma f of a. Okay? This is technically like your x sub 1 comma y sub 1. So now if I add the y sub 1 to both sides, I get y is equal to m times the quantity x minus x sub 1 plus y sub 1 on the end. Well, y is really like my linearization, right? All of x. And then m is actually f prime evaluated at a, right, times the quantity x minus a plus y sub 1, which is f of a. So we have to go through this process, and if we crank through this process, when we're done, we'll end up with this line here. Okay. So the first step will be to do f prime. So what I'm going to do is I'm going to say that f prime of x, we use the power rule. So we're assuming that k is a constant, so we toss the k to the front times the stuff on the inside, and then this is going to be k minus 1, and then times the derivative of the stuff on the inside, which is just 1.
Yeah, but that's where I'm confused, is how it equals 1. Or not that, when you take f of 0.
Okay, so the first thing that we need, so we're interested when x equals 0. So now what this means is that our linearization is equal to f prime of a times x minus a plus f of a, right? And technically we're interested when a equals 0, sort of, right? All right. So my linearization, what is f of 0? Well, f of 0 is equal to 1 plus 0 raised to the k, right? So then that means that f of 0 is equal to 1 raised to the k. Pick a number for k. We don't know what k is, but pick a number for k. 3. What's 1 to the third power? 1. Pick another number for k.
7.
What's 1 to the 7th power?
1.
1. So no matter what we plug in for k, f to the 0 will always equal 1, no matter what k is, for all k.
So do we even need to write the k there?
No, we could just assume that f of a is 1.
Okay.
Okay, and then from there, now we need to do kind of a little bit similar thing, because now we need f prime. So if I want to evaluate f prime at 0, now I've got k plus 1 plus 0, and then k raised to the k minus 1. Now this one gets a little trickier. We've got k times 1 raised to the k minus 1. Well, what's this always going to be? 1, right? No matter what value, I mean, it's the same thing, we're just saying k minus 1. So we're always, this is always going to be k times 1, which is really just k. Does that make sense? So now if we come back, that means that this will always be what? K. Right? We're almost there. Well, that is going to be x minus 0 in here, so my linearization, k times x is just kx, and if I rearrange it using the commutative property of addition, I get that. Does that make sense?
Thank you.
You're welcome.